So, welcome to our first episode of the AI Ascent Podcast. This is the podcast where we'll peel back the layers of the AI world, revealing the intricate webs and exciting advancements in artificial intelligence. Our first guest is someone who I've had the pleasure of knowing for the last 4 or 5 years. I initially reached out to him on LinkedIn back in my college days, and our virtual meetups were full of fascinating conversations about artificial intelligence. As we dive into our discussion today, we will not only explore his current projects and consulting work, but also his insights into the potential of the open source community in AI development, the regulation of AI, and new AI tools that excite him most. Welcome, Codie. Thanks for joining us.
Yeah. Thanks for having me. I was excited you reached out and took a look at your channel, and I thought it was, you've grown pretty quick, so I was pretty excited.
I appreciate that. Yeah, I started out with just 11 subscribers, maybe 1 or 2 months ago, and now we're over 1,000. So that's really exciting to see.
Nice.
Yeah. So do you want to do a little introduction before we go into the questions?
Yeah. So I run a kind of like an emerging tech type like company. We help other companies when they don't have the experience in like either AI, blockchain, digital twin type stuff, right? So we don't really do like a lot of the development work. Like we'll do kind of like the pioneering MVP type stuff. So more like special forces rather than army type stuff. Like we don't really have the manpower to do an entire project, but we do all of the pioneering things that you would expect to find a product market fit and stuff like that. So we're working on a couple of projects. We have a NASA project that we're on, and we're helping like do the rover simulations and doing conceptualizations for different tooling, and then simulations of like plume surface interactions, which is like when the thrust from the rocket comes out and then it tries to push away rocks or dust or whatever materials are down there. So that's pretty important for anyone building anything down there, right? So we do a lot of stuff, but I started in gaming. And as a game developer, you're going to run into a lot of unique problems that you have to be kind of creative with solving, like tech limitations and all of these other types of hurdles with hardware. Like the gamers, they want like the best, right? So you got to push,
Yeah.
you got to really push the boundaries of what is even possible and the hardware itself. So that turned out to be useful in a lot of cases, and that's how I got into like this deep tech type emerging tech industry, I guess you'd call it. It's not really a single industry, but there's a huge need for people that can kind of swing with the punches.
For sure. That makes a lot of sense.
Hmm.
So yeah, to dive into our questions here, what kind of projects are you working on currently?
So in terms of just my normal work, I have the NASA project that I just mentioned, and then there's a couple of well, I can't really talk too much about them, but there's a couple of people who really want to automate not just like one specific thing of their company, but they want to automate some of the human level thinking that is traditionally done by like a clerical staff or whatever, right? They kind of want to automate that away with these new LLMs. So we're making like different frameworks and stuff like that. We'll probably release some of the work that I've done as open source eventually, just because it's moving so fast. You can't just like keep it proprietary and then think that you're gonna have the lead for X amount of years, right? So you got to work with the community and get as many eyeballs on it as possible. So I think there's a lot of things that we could benefit from if we go open source, and I think it's really it's going a lot of different directions right now with the LLMs. There's people trying to do, and there's a whole company just making NPCs with open AI type stuff, right? So I don't know exactly where we're going to fit in and like find our niche that we can really support, but right now it seems like it's going to be like office space, like assistants essentially. So I think that's
Nice.
the best work that we got going. And then we have other side stuff like blockchain development and whatnot.
That makes sense.
Mm.
For sure. Yeah, I remember you were talking about autonomous agents. How are you currently using autonomous agents at your company in your work?
Oh, so we have like this little persona framework that we're building out. And the idea is that we kind of get all of the main features that LangChain, semantic kernel, and kind of OpenAI's kind of like planning type software. OpenAI, they don't have it exposed in how they do it, but LangChain and semantic kernel are open source. So they've kind of shown how they get this AI to come up with a list of plans, like a list of like how to get certain data, and then how to enact the user's request, and then how to parse that in a certain style. So that's kind of the core framework we need to work on. And I like the way Microsoft is going, but they have like a bad habit of like letting their projects die just because it didn't pan out the way like there's people building their things around, like take the Zune for example, right? There's like app developers and people trying to develop for the Zune, and then they're like, it's not our thing, so like a whole market goes away. So this framework, the whole idea is that you'll have like interfaces in the back end that are using either LangChain or maybe OpenAI, like kind like expands their offering on their module that they have right now in Python, and semantic kernel. But semantic kernel, I hope they continue with it, because they're doing, in my opinion, they're doing a lot of pioneering work that people are trying to like keep secret sauce for themselves. So I'm hoping that they continue with it because they got a pretty big open source community around it already. So, but I got a plan to make sure that they don't just end it. But essentially, what we're trying to do now is have like an intern level programmer. There's a project, I forget the name of the guy who made it, but it's called GPT Engineer, and it does pretty well. Actually, I was pretty surprised, especially with how few tokens it uses, and it can essentially bring out the bare bones of your project, and then you only have to like tweak a couple of things to get it working the way you want. So, I want to start offloading some of the work that I'm doing, because that means I can work on like the more detailed business oriented stuff, like talking to clients and like hashing out contracts, and then I get like 2 or 3 hours of infrastructure code gone, right? So I just don't even have to worry about it. So there's that, and then I want to integrate it more directly into the way I reach out to people, because it's a lot of it's a lot of work. Even if you use GPT, you have to explain every single client, right? You have to say, oh, this is my client, this is the whole project, now please make something like an email related to this and saying these things, right? So what we're working on is this persona framework. It will essentially reach into like every part of your work folders, right? So it'll have access to just a certain like partition or a separate hard drive that's only work related. I'm sure most companies will have just work computers, right? So they'll have access to everything. But the idea is that it will summarize every form of communication, every project file that you have, right? And then it will summarize it saying like how it's connected, any to-dos that it needs to go through, like maybe an AI is cleaning it up or making unit tests or whatnot. But in our case, I want to talk to GPT, but I want it to already know the things that I have going on, right? And I don't want to have to explain it like with like a bunch of chunked out text just thrown in there every single time. So one of the ways is you have to set up a pipeline for all of your company's communications and relevant information to be fed into like a vector database of some sort. So that's the biggest thing that we're moving to, is just like automate all of the business processes. But first, you have to automate all of the data collection about as many points as possible from your company. So that's the framework that we're working on right now.
That makes sense. That's pretty interesting. Especially that part towards the end about the vector databases. So have you been working with the vector databases already? I remember working with like private GPT in order to get a vector database working locally on my computer, which was pretty cool. Have you done any experiments with it?
Yeah. So we pretty much only unit testing right now. But we use Pinecone and the Chroma DB. And I haven't integrated ChromaDB directly into the as an interface for different memory backends yet, but it kind of works the same way, just like different language and stuff. So in programming, there's something called a database access object, and the idea is that you don't know what type of database that you're going to use, right? Same concept for object oriented. You want to iterate a bunch of times, but you just want to have an object that you can access rather than some sort of data oriented programming. So a data access object is some way to abstract away all of the like uh all of the back end details of a particular instance, and like so I can do SQL or SQLite or Redis or whatnot, but it's all going through a similar interface. And that's kind of what we're doing for all these memory databases, just making a single interface, because we don't know who's going to come out on top. And some of the brain inspired work that I do, I think will eventually replace these vector databases. But the way we use it right now is to kind of get the user's semantic search. Everyone's doing that, right? So it will find similarity to what they're looking up and inject it directly into the prompt. But then also, one of the more powerful things I think is the AI is creating its own thoughts on like what it's like some side thoughts, but maybe not their like steps or something, right? Like chain of thought reasoning or something like that, and it's saving them as like future to-dos or whatnot, and then it can also pull those into it in a separate step. So you have the semantic similarity search for the user's query to bring in relevant information, and then you have the internal thought process where the AI is injecting its own any potentially relevant previous thoughts it had on the same or anything it's tried before. So that's what we've experimented now, but not too much, but enough to like run through maybe I'd say like 2 or 3 days of testing. So
For sure. Yeah, stuff like vector databases are really, I would imagine, could become really powerful very soon just because of how it enables these LLMs and autonomous agents to be able to have a full long-term memory and to be able
yeah,
to look up information that's important and just bring it in and start using it. So yeah, that's all really exciting that you're doing stuff like that. Like I would imagine in the future, potentially having LLMs that are connected to vector databases where the vector database is filled up with all of the works of a particular person.
right.
And so it would even be possible to talk to the person and the LLM would have access to all of the works of that person and would be able to respond based upon that and be able to even reference the parts where he actually talks about it, he or she.
Yeah.
So
There's actually I don't know if you're familiar with Ray Kurzweil.
yeah, I've seen
Yeah,
some
yeah.
of his stuff.
Yeah, so he's like a futurist for anyone who doesn't know, but he's been in like the transhuman futurist type movement, and he talks about doing that for his dad that he like really respected, and he passed away. He kept all of his files, like all of his recordings and stuff like that, solely for that particular task, so he can like bring back a persona of his dad or whatnot. So I think there's like a lot of potential for cloning personalities. Like maybe you have a model that's good enough to accurately portray humans based off of writings, right? And then you can bring back like the thoughts of Washington or like other great thinkers like Thomas Paine or something like that, right? Uh, Maybe it's a bad thing because you're like, oh, this guy wasn't that wasn't that great. Like maybe it humanizes them too much, and it kind of takes away the like the allure of like a founding father or something, right? But in another hand, you can ask things that weren't necessarily possible before. Like you always had like third hand perspective, and in a sense, it's still third hand perspective, but it engages like in particular kids. I think it would engage them more in like history and learning about like where they came from and stuff.
Yeah. That makes a lot of sense for sure. Yeah, Ray Kurzweil had some really interesting uh, discussions and gave some really cool talks. I remember he was also talking about stuff like biological immortality potentially
Yeah.
by 2030.
Yeah, what was it? GNCR, that's his like little singularity thing. So genetics, nanotechnology, robotics, GNCR, I forget. But he had a list of the emerging technologies that he thought would be super popular and like speed us up towards like this singularity, which is where like our predictions like are no longer relevant, right? Which I kind of say like there's always a point like that where our predictions are never right, right? So like 100 years ago, no one would have expected us to make the stuff we're making today, right? So in fact, there was a Civil War veteran. He died, but he lived through the Civil War to see the use of atomic weapons, and he took a photo in front of a MiG. So could you imagine? No way they were able to predict anything like that, right? So I think uh, I think something like the singularity, like it's like a cool tech type hype thing, but there's always a point where you can't see past just because you have like a limited understanding. So
That makes sense. Yeah. So to go on to the next question, what kind of consulting projects are you open to taking on? What type of work interests you the most?
so pretty much anything in the emerging tech type type field, I guess you'd call it. I really like pushing myself in like new scientific fields I don't have too much experience in just because it's always been rewarded. So now it's like baked into my behavior. I just like taking on things that are way outside of my field and like usually pairing up with like say if we were going to do something in DNA, right? We would pair up with a scientist who really knows how to explain things well, and then we can extrapolate like what we need to do to make a software that's relevant for them. And that's where we would like do all of our learning, but we get to make some cool software and help out a specific industry. Some of the things that we're doing right now is just like the AI, the blockchain. And I really want to stick with the AI because I went through the whole blockchain hype cycle, and it peaks pretty quick. But then if you can get in early enough, you can find those clients who are actually pretty serious about it. I think maybe we got into it a little bit too late because the first LLMs weren't super useful enough for anyone to do it, and then all of a sudden it was useful, right? So it's kind of
Mhm.
hard to like weed out the noise and just get the signal. So I'm more interested about the people who want to do like large transformations of their company. Like the apps are kind of cool, but that's kind of limited, right? Like you have like these powerful things that can deduce anything from natural language, and you just want to make a single app. Why not like transform a whole industry or a whole corporations like the way they do business, right? That's more of the stuff that I'm into is like pioneering something new. I don't really like doing the training anymore, like the AI training, just because it's tedious. Like I mean, you are in the AI industry, right? You know how many hours you'll sit there just to get bad results. You're like, oh, back to the drawing board, right?
Yeah.
so, so yeah, I'm not a big fan of. When I first started out, it was kind of fun, but I'm not too much of a big fan of that anymore. And quite frankly, you're gonna fall behind if you do that. Like if you want to train something from scratch, everybody else is way ahead. So you got to kind of keep pace until people find out where the settling point is.
Yeah, that makes sense. Yeah, for sure. Training a model from scratch has become less and less viable the more
Yeah.
advanced that we become. Like in the past, we could train a state-of-the-art model with tens of thousands of pictures, but now it would take way more. And now we have these LLMs where they're pre-trained on 1.2 trillion tokens or even more than that.
Yeah. Yeah.
Yeah, and it takes like 400 or more GPUs over the course of several days in
Yeah. And
order
not
to
just,
fully go through that.
yeah. Yeah. Not just those little wimpy GPUs either. Those like, I don't know how much, I think they're like 30,000 last time I checked. There's like the A100s or something.
Yeah, the A100s. Yeah, they have the 40 gigabyte and the 80 gigabyte versions.
Yeah.
So,
Yeah. Yeah. So past the little startup that can do it by themselves type training.
yeah,
Hmm.
yeah. I think it's really cool to see, though, that there has been a trend towards more open source. Uh, availability of some of the LLMs. So once they pre-train it on all of this crazy GPU compute power, then in order to do like the fine tuning, now we have the capability of actually being able to do that on a single GPU. And
Right.
so that brings in a lot of the cool stuff, but for sure the state of the art stuff running like a 130 billion parameter model
Yeah.
currently with today's technology, we could run it on a single computer, but it just wouldn't be that fast.
Yeah. It actually reminds me, back in World War II, the Germans, they were like sending out like mass waves of these little fighters, right? And when the Allies were like kind of dissecting the technology, they're like, how did they get these plates? They're like a really important piece of the plane, but they were stamping them out all one shot. And it turned out they were these big, massive machines, that these massive presses, like multiple tons. And it became so important to have these like foundational technologies, just like we see today in like fabs. And I think which we'll see to in a little bit in the future, not right now because people can still do it with enough money, but in the future when it takes really long time to train these things, I think those will be just as important. Like the Russians and the Americans, they split up these they took these these massive machines just so they could have that production capability that the Germans had. And I think you'll probably see models so big that no one can do it, and you just have to like pay for access to it. And that it's kind of sad because that's going to limit who can do it unless they bring down the price enough that anyone can do it, right? But it's kind of scary in the sense that you can have so much power and productivity like locked up in one place with something as important as artificial intelligence. So
Yeah.
mm,
Yeah, that makes a lot of sense
mm,
for sure. Yeah, it's very interesting. There's kind of the trend where some of the state of the art models are very large and powerful and require tens or hundreds of GPUs to run, even for inferencing. But we also have models that are available for open source that can be run on a single GPU. They're a lot smaller, but
yeah,
as I'm sure we'll get into, I think that's one of our questions. There's a gap between the proprietary models and the open source models, and it'll be really interesting to see how that gap will close in the coming weeks or months, if it does close at all.
right. Yeah. I think, yeah. Well, I guess we'll talk about it. But yeah, there's some interesting insights on those smaller models actually, and why they are even close to competing, and why they might not actually be able to keep up with the trend.
And so before going into the next question, I just wanted to make sure to shout Codie out. He's open to doing any type of consulting work as he discussed earlier. And also, Codie, where can our viewers reach you in case they want to contact you?
You can look up Asteries Technologies. It was an unfortunate naming choice because we found out a lot of people can't spell it directly right off the bat. So I guess I'll give you a link and you can put it in the thing. And I'll have
Yep.
the email address that you can reach to inside there.
Awesome. Yep. I'll make sure to include all the information to contact Codie in the description below. Cool. To go on with the next question, could you explain your work with Sparsey?
Yeah, so Sparsey is, well, I'll back up a little bit. So in 2017, I had joined an AI startup in Spain, and we were just like kind of doing just like your generic training. We made a framework that was 3 times faster than TensorFlow, which is Google's AI framework, and we were shopping it around in Abu Dhabi and stuff. But it just 3 times wasn't fast enough to like justify all of the engineers like unlearning what they just learned and then picking up a new one. Back then, it was kind of moving a little bit fast in the research field, and no one wanted to relearn a framework from scratch. So that ended up not working too much. But while I was researching some of the stuff, we were still trying to hold on to the dream that we could be useful to the AI industry in some manner. So I was reaching out on all these novel ideas, and I ran across a company called Numenta first, which is like a brain-inspired algorithm. Well, it's a institution that researches brain-inspired algorithms, essentially, mostly around the cortical columns in the brain, the neocortex. But then as I was digging deeper into the reasoning, I ran across the kind of like the originator of the work, and that was Gerard Rinkus. And his algorithm was called Sparsey, and it's built directly off of some inferences that you can make from like how the brain is being activated and these like different like temporal codes or whatnot. So a lot of people think in the brain, like the computational neuroscience, they think that the codes are locked in the spikes themselves. But like, so if I have like a kind of like Morse code for the brain, right? Like each neuron is sending out a code, and then that triggers like another neuron to do a thing, right? But what Rinkus deduced was that it wasn't actually the repetition, like the pattern from the signals that was like generating these useful codes. It was the configuration of the neurons themselves within each cortical column. So in the cortical column, you'll have like a single mini column, which is like 100 neurons linked together. And the moment one of them fires, the other ones are inhibited from firing. So you can imagine that as like a bit, right? So I can have a 1 or a 0, or if it's like decimal, I can have a 0 through 9, but I can't have multiple in one single digit place, right? And then in a like a macro column, which is just like 100 mini columns essentially, you'll have 100 different codes that turn on, right? So you can have 100 to the power of 100 different codes just in a single macro column. And he was saying that this is where the usefulness of the brain is kind of like just like the brain and or just like the computer is storing information as ones and zeros. It's storing it in a different base pair, or like a base code essentially. So it's doing hundreds or 80s. There's like it's not uniform across all of them, but essentially the idea is that every single column will have like a feature representation like below it. So like I have a field that it can see. And if I see like two dots and a little smiley face underneath it, one neuron will fire, right? But if I see a frowny face underneath it, a different neuron will fire, right? And then all of those codes kind of like reinforce each other. So if one happens to be wrong, it's still pretty stable code because all of the other ones are representing it just with a different mini column, right? The cool thing is when you do that in like a massive field of these little macro columns, right? So you'll see like maybe a happy face here, another happy face, another happy face, and then on a like a macro column that's further down the line of processing, it will deduce that as a crowd, right? A happy crowd or a sad crowd or whatnot, and you'll just have one macro column looking at that type of feature field and like deducing just by simple like saying I'm only gonna fire for Jennifer Aniston's face or something like that, right? Just like a neuron specifically tuned, or like a set of neurons, a code specifically tuned to firing for a specific feature of some sort, whether that be sound or sight or taste. And the cool thing about that whole idea is it's not just visual representations or auditory. The codes are uniform in the sense that you can swap them out between it. It's going to represent them all in this sparse, like this sparse representation of the code, right? So the other second most powerful part about it is like, okay, you can classify these things with a single macro column. We can do that with normal neural networks, right? But the powerful thing behind it is the fact that when you have, like say I have a bunch of neighbors, right? They're all going to fire. But on the next time step, like after they fire, like they keep on firing, it's the brain, right? You're going to get the codes from your neighbors, but of the last time step, right? So now you have temporally contextual information for that code. And maybe I saw a smiley face go to a frowny face, right? That's a representation of someone becoming sad because you have the temporal codes that have changed which neurons fire. It's still going to have overlap. It's going to have a similarity with happy faces, but then you have like a branch of multitudes of different things that you could go to. Happy face becoming angry or happy face becoming sad. So I thought it was pretty powerful because it gets everything that the AI industry has been like poking in the dark to try to find, right? Like no one said like, oh, this is how the brain works, right? They said, oh, this is statistics and we need to statistically pull these things out of data because I don't want to do it by hand, right? And Sparsey, just his like inferences from how the brain was showing the codes, he was able to do something. Maybe it's not perfect, right? But he was able to understand the brain and a new way of like capturing temporal context that nobody else really like really thought of. So I was like, if this, I actually told him this. He's like, that should be our model, his company's model. I said, if this isn't the way the brain works, it's the way it should work, right? Because it's such a powerful idea, and you don't need transformers, and you don't need like all of these other different like attention-seeking things. It's gonna naturally pull it out, right? So it was funded by some of the National Institute of Health and then the Office of Naval Development. So he got some funding to do it. It was his PhD thesis, I think. He's like spent his whole life around it, but everybody's kind of hopped up on the hype of like LLMs and like more accurate cat pictures or something, right? So there's not too many more people that want to do research anymore into these computational neuroscience like brain inspired algorithms. So it's biologically possible. I don't know if it is exactly how it's doing it, but it gets really good results. You can it's not as good as state of the art because he's just one guy and then I help him do a little bit of research with it. But it's kind of sad that to be honest, that a lot of people don't take it seriously. It's a pretty powerful algorithm.
That makes sense.
Yeah.
I think I remember also when you were in it, like when you were working at it
Oh
at
yeah.
your peak in that part of it, that you were
Yeah.
talking about how some other groups had also started coming up with the idea of the macro columns at the same time.
Yeah. So the not necessarily the macro columns, but they the way he was pulling out the information, like the way these codes were being built, people were independently discovering these same things. So there's a fly hash, and then there's another one with moth olfactory, which is the way they smell. They come up with almost exact circuits and ways of describing how the process works, as Rinkus came up with like 20 plus years ago. And that's how you know you're onto something, is when everybody else is independently finding the exact same types of techniques that you've been working on pretty much your whole career, right? So yeah, I think one of the reasons I'm still hopeful about it getting injected into the current AI hype that's going on right now is that these LLMs, they're like cool and all, but they're only going to be able to pull in like text-based embeddings, right? What I mentioned with the the codings, the coding fields, they can be swapped between any type of like signal. So whether it be auditory or visual or even text, right? You just need to come up with an encoding method that converts it into a sparse binary signal, and that has natural similarity. It's called Hamming distance, and basically you just like if I have a number, like a set of zeros and ones, I see how many ones overlap essentially, and then you just increment one. So if only one zero or one is not being represented, then it has a distance of one. If there's two ones that are not being represented, it's a distance of two. So it's pretty simple similarity search, as long as it's sparse. That's the key. It has to be a sparse algorithm, because then the probability of like clashes, like hash clashing, the probability of those overlapping is so low that it's like really hard to get a false positive essentially, or even a false negative. So that's the key. So I'm part of that persona framework that I was talking about. The reason I want that back-end interface is I'm hoping that Sparsey can be the similarity search engine that stores these like multimodal data formats. So whether it be like a video with text paired together, because then if I have a representation for a video and then a text like of a man screaming or something, right? I'll be able to see all of the things that have a similar overlap with it and pull in video and pictures and 3D models or whatever that might be related to that code, just because you're encoding them in the exact same way for every piece of data. And I think that's what will get you to that multimodal AGI level. I guess you'd call it like the holy grail, right? The multimodal, like it could do everything. And if you just think of Sparsey as an experience capturing device, then it makes sense for it to be to replace like the vector databases, which is kind of crazy because Rinkus and I we a while back we put in a Y Combinator thing and we were talking about we didn't know it was a vector database, we didn't know what to call it, but we were talking about a database system that could do this like constant similarity search type thing. We thought like, oh, it'd be useful for Google search engine or something, right? Maybe we pitched ourselves wrong, but now like it's the hottest thing since like AI itself is vector databases, right? So so yeah, I guess we were a little bit too early on that and didn't really apply it correctly in terms of like what we thought it could have been useful for.
I see.
Hmm.
That makes sense. Awesome. Really interesting stuff with the Sparsey that you were talking about. I always am intrigued to hear about it. So the next question is, given your experience in game design, how do you foresee the evolution of video games as generative artificial intelligence becomes more prevalent?
Yeah, so it kind of sucks because I like doing game development, but I don't like doing it for a job too much anymore, just because like gamers are the toughest toughest customers you're ever going to work with. There's always something little, like if it pisses them off, they're going to let you know, right? But I'm always thinking like, man, I should make a game, but I know I don't have the time or patience to like tweak a full game anymore. But one of the first things when Midjourney came out, it was a like a like the you do / imagine and you can come up with whatever, like whatever image that you want. It was still in like the artistic type look. It didn't have the like the realism yet. And my brother and I, we were talking about like, oh man, you can make a procedurally generated game with this, right? One of the biggest things for me as a game developer, I like playing games to uncover the content. But as a game developer, if you make it, like all of the content's uncovered already, right? Because you invented everything. But one of the things we always like the idea of is like massively generated worlds where you can just explore and do stuff and like find out new technologies and whatnot. And one of the ideas was RTSs, real-time strategy games. They always have like a problem with once you find a build or a strategy, you just gun for that technology and you have like this template that nobody can beat you because you have like the best. You've algorithmically through like like testing out like, oh, I'm going to test this one, but you've made a player algorithm essentially that says just do these things and you will win, right? And that was always disappointing because half of the fun of an RTS is coming up with a new way to beat your opponent. And we thought like, well, what if you did like new technologies every time, but you'd have to come up with a huge art database for every type of technology. But then that's when Midjourney came out. Like, oh, well, what if you're going to a planet and instead of seeing this like little template of an art picture of like the scenery, you just have like a kind of like a description template that describes icy planets or jungle planets, right? So whenever you like park your ship in orbit, like a space game or whatnot, you'd see all of these like new pictures every single time, and maybe you can convert them into NFTs, right? You can say, oh, this like art for your planet is now an NFT, and you can You say you found it, and then you can sell it on like whatever, right? And then in the same tone, you can do that with technologies and resources. You can make like different types of guns and generate the pictures for the weapons or for the ships or for the resources that you're finding. And there'll always be fresh content, right? Before this whole generative AI art idea came about, people were like on this hype train for like user generated content. But the problem is, like users, they'll make some weird things that are not appropriate for for your game, right? So you have to all of this content moderation. But with AI generated one, you give the user just enough to like express themselves, and then they can pull that art generation process into their own process of discovering, right? So if I want to like say I want to like play this space game, but I want Gundam like fighter jets or something like that, right? You'll start moving your way just by reiterating, just like you would do in like Discord for Midjourney. You'd say like, oh, make a variation of this one, make a variation of this one, right? But instead of making variations, it's a tech tree, and then you'd have like little they would invest in research in one of these new technologies, so it generates a new picture, and then maybe four more branches of technologies that you could go to with all of these different stats and different material requirements or something. So I think replacing the user generated content loop with like AI guardrails, that could probably remove much of much of the moderation headaches that a lot of these like Roblox and stuff have, right? And then not to mention like interacting with NPCs fresh every single time. In the same way with the RTSs, every time you want to do some diplomacy, it's kind of like a like, oh, just get your meter up to the thing, right? But imagine trying to like convince this AI to like go like destroy a planet for you. Like, no, trust me, it's for the better of both of us, right? If you're like trying to like convince them to use like X amount of his forces and then make a deal with them, and then they'll have like a little bit of context just within the game, within that single game, just so it doesn't get super powerful and it can always overpower every single player it comes across. But it would be an interesting way where you're chatting to the AI just like you would a human, trying to convince them, and they'll have like their own personality. Maybe they're hot-headed, take offense to the use of I instead of we collective, right? Maybe it's like a insect race or something like that. So I think there's a lot of possibilities for interacting with players in like a more dynamic way than people have. So I guarantee you, the gaming industry, they'll exploit every single way that they can to do it. So I'm pretty excited about how people start using it in their games.
That makes sense.
Mm.
Yeah, it reminds me of how we now are able to connect these open source LLMs up to model cards. And
Yeah,
with the model card, you can pretty much give it any background that you want. And then now it's adapted to that persona.
yeah. It's actually, I don't know if you've seen, what is that, Westworld, the show Westworld, where they have like the person making the backstory for every single AI. It kind of reminds me of that. You're like putting these like fake images in their head and like, oh, remember when your dad died? Like, what? No. Yeah. So like it's kind of, I don't think they're conscious. So like it doesn't matter, but something to pay attention to. Like science fiction has kind of already gone through a couple of these. You were mentioning the like these AI that are built solely off of the persona of like an artist or an author or something like that, right? I think Her, the movie Her, did that with Joaquin Phoenix in it. And the AI just like decided to leave humans because they sucked and like, oh, we're beyond you now, and then they just left. But so I think uh, the recent science fiction, maybe not like the old like H.G. Wells type of science fiction, but some of the recent science fiction, there's a lot of good ideas on like some good things that could happen and some pretty horrible things. Not Terminator. I don't think we're there yet, but I think there's a lot of good ideas in science fiction. And if you feel like you're not creative enough to come up with these ideas on your own, one, just use GPT, right? But then two, like kind of like dig through some of the old science fiction books and start seeing if you can connect them up to GPT and like describe your ideas to help you come up with like creative ideas for gameplay or even for movies or something like that. So
Yeah, yeah, that makes sense. Yeah, it's very interesting. Especially that part that you talk about how it's similar to Westworld, because
yeah,
in addition to us developing these model cards and being able to use generative AI to create personas, we're also seeing all these developments in robotics and
oh
animatronics
yeah, yep,
and the ability to potentially create, you know, like an entire theme park where you can go there and you can
yep,
interact with these super lifelike people or whatever type of video game character
yeah, yeah.
and have just a full conversation in theme and have an entire park just dedicated to some type of subject matter.
Yeah, like Disneyland, don't they have like a
Yeah.
Star Wars theme park? Yeah, yeah. So just like do all of the characters are animatronics and you talk to like Boba Fett or Jabba the Hutt or something like that. And just
Yeah,
like do it
to
naturally. Yeah.
exactly. Yeah, creating like a whole world with all where you can actually go talk to all of them.
Yeah, yeah.
That would be really cool to see. Potentially pretty expensive to attend in the
Yeah,
beginning,
yeah.
but definitely worth it. Awesome. So also another intriguing concept is brain implants. So what is your perspective on the impending advent of brain implants, especially in the light of recent developments such as FDA approval of human trials for Neuralink?
So there's a lot of people doing brain computer interfaces. I know like Elon, he gets like a lot of the credit for it, but there's a bunch of other companies that do BCIs, and they've been doing some pioneering work. I'm not actually sure how Neuralinks is going to work out because one of the biggest problems, like you have for like seizure patients, for example, I have seizures, and if I were to get a like a brain implant to stop them, the biggest problem is like your brain is not like it's not like a bone, right? You can't I can get an implant on my bone, it's fine, but in your brain like floats around, and any wires like tethered to it are just going to be like yanking at your like so it's not very plausible to do it just for aesthetics or like maybe you want to cyborg yourself up, which I would totally do if it if it didn't damage my brain. I'm totally down for it, right? But it's not really plausible with the technology as it currently is. I'm sure they'll go to like a. I think they were talking about. I don't know if they implemented it yet, but I think they're talking about doing like a wirelessly like an RFID reading, so it like powers the device that's actually on the brain, and then it reads the signal back from it, but I don't know what the results are like for that. So, but there's other interesting possibilities where you're just using. I didn't know this, but infrared light can penetrate the skull, and that's how they do these like little brain mapping things with all these like little um, like electrodes on your head. There's a company that's doing like this little headset that you can put on, and you get like really highly accurate brain scans and neural activity. I'm pretty hopeful for the direct brain computer interface. Um, and I hope it's as cheap as the LASIK as well, because one that's going to transform a lot of people. Like a lot of people will need it, not just like the people who think it's cool, right? Like paralyzed people, maybe they can start walking again. That same technology you can use to like say there's a spinal break, right? You can use that to like jump that gap that has been made, and maybe have like an adapter that sends the correct signals back to your legs, right? So that's like the first step. But in terms of like long-term thinking, expanding the human, like the human capacity for thinking, I think that's going to be even more powerful, obviously, than just like making people not paralyzed and stuff like that. Because if you can get a biologically like plausible AI model, like something like Sparsey or even Numenta's to an extent, um, what happens is a machine that has the same coding system that you have can interact directly with your brain without any like weird like signal conversion or a neural network trying to learn it and then send the correct signals back. It will just be like adding on, just like mammals evolved by adding on more and more cortical columns as they went from like mouse to man. Um, they just added more cortical columns. That's all they really did. And these types of digital interfaces, if you can map the way a cortical column um, like actually outputs its signal, you're essentially continuing that evolutionary process of expanding the brain, but in a digital manner, right? So the brain already, it's like split. I forget what there's something right down the middle. It's like a bunch of like neural connections that allows the brain to communicate between both halves. And if you cut right down the middle, like some people have to do it when they have seizures, they have really, really bad ones. It's only one part of the brain that's responsible for the seizure, and then it travels to the rest of the brain, and it's like a cascading effect. So some people have had it cut, and there's one guy. He's pretty famous for this particular effect, and his eyes will see like two different things, and but they'll like be drawing, but he won't know what. Well, the side of his brain that can talk doesn't really know the what's happening on the other side, right? Like he has to say it out loud so his ears can hear it, and that's how that's how he communicates with the other half of his brain, right? So in a way, that's kind of what we're doing with AI right now. We're saying it out loud, so the AI knows what we're doing. But at some point, it will be directly integrated, and will be, I imagine, will be something kind of like our like old reptilian brains are to our mammalian self, will be to this like larger AI. I don't know, like the Borg or whatever, right? We'll have we'll have a similar relationship where we're kind of generating some of these needs and requirements, but the like the larger digital cortex is it's kind of like doing all of the major higher level thinking, the organizing society and stuff like that. So that's like 100 years or something in the future, but I think it's a pretty cool concept to do direct brain computer interfacing, because that's really the only thing that sets apart from any other animal on the planet. So got to keep that trend going.
That makes sense. Yeah, very interesting. Yeah, it's really cool to see how there's other competing companies as well, such as BlackRock Neurotech, who they've been doing human trials since 2017. So it's
Yeah,
been
yeah, yeah.
several years right now.
Yep. And then there's I think it's called Kernel, but it's like that's the headset group there that we're doing that. It was like not invasive, and I think probably not as powerful, but it's still pretty cool for maybe like a fighter pilot or something like that, right? But there's a bunch of different fields. I have a feeling the surgical route is going to be the best route, but I'm not really an expert on the thing, so I could be completely wrong, right? So
Makes sense. Cool. So next is that question that we were initially talking about earlier in the conversation about. So do you believe that the open source community has the potential to equalize or perhaps even surpass proprietary models?
so with there is a business model for open source, right? But the way for anyone who doesn't know how you make money off of open source, the idea is that you're going to make a framework, and initially you're going to use it for like a couple of clients or something like that. And then what you'll do is you open it up to the public, because they're going to be able to contribute, like say Google or something, right? They're going to use it, but then they're going to have their own specific use case. And then Google has to contribute, just because that's part of the license. They have to contribute whatever changes they've made to the open source as well. So it gets better the more people use it, and you don't really have to lift a finger to make it get better and like implement all of these use cases, right? So any model that goes the route that wants to keep up, it's going to be somebody that has their own personal agenda, right? Which is fine, your business, but they're going to want the public to like I think the license behind it is going to make sure that whoever is generating the models, those models also have to be public for other people to use and for the company who first invented it. So like Cerebras, they're like a massive computing company. It's like they use like wafer scale computer chips, like huge computer chips, not like these like little tiny postage stamp ones. And they're helping train like these really large models. And I could see them quickly pivoting to it's not meant for AI specifically. They're just like a general high performance computing platform. But I could see them becoming like a big player in the open source AI, where they're making these AI models for their clients, and then once it's made, anyone else who comes up to them can they say, yeah, we can do it for free with your data, but that model also has to be open to public, or you can just pay us, right? I think that's a way that you could contribute. But the problem, like I mentioned, with the whole German, the presses that the Germans were kind of hoarding and using, um, it's kind of like a one-man show, right? It's not, you can't contribute too much to like this massive thing that's already built and it has a whole pipeline, right? So I think there's going to need to be, in terms of just the models themselves, not necessarily the frameworks. The frameworks, everyone can be contributing to open source AI frameworks out there, but the models themselves, I think it will be increasingly difficult to contribute in a meaningful manner. So I could see the people who are kind of far behind right now opening it up to the public. Maybe they do like a federated learning system or some sort of more complicated thing that the community can't set up by themselves because they don't have the technical know-how to make these distributed models. I could see them leveraging kind of like a SETI at home, where you're using your own computational power to help train different parts of the model or something. So we'll see, but it has to be somebody who's kind of far behind, maybe like Google. And I think if they were to say, you know what, let's play on our whole Google's not evil type type mantra, and then just make an open source model that people can contribute to. I think that would help them like move pretty quickly. So if there is any sort of open source initiative, whoever starts the initiative itself is going to have to gain monetarily from it, or else I don't see like a bunch of like people like coming together and making a big model for nothing. Like it's a heavy investment, right? So I mean, unless the government funds it, but um, yeah, I don't know. I think
Mm,
it might be rough, but we'll see.
yeah.
Mm.
Yeah, it'll be interesting because I remember last year we were talking about, or we were seeing in AI how the models were all in their 32-bit form, and then we got the mixed precision breakthrough, and then from there we were able to move the models down to 8-bit and still get the same level of performance, and then we were able to move it down to 4-bit and still get the same level of performance, but just for inferencing. And then with the QLoRa paper that came out a couple weeks ago, now we're able to actually do fine tuning of a model also in 4-bit and still have the same level of precision as a 16 or a 32-bit model.
Oh,
And so,
nice.
yeah, stuff like that's really cool to see how we've gone from having a 32-bit model all the way down to getting it to a 4-bit size. And it seems at this point that that would be as far as we can go. I can't imagine that we would go lower than 4 bits. So then I think now the other advancements are going to come from maybe data and architecture. And
Right.
really what I see is more of the data side. Just
Yeah.
having better data, you know, being
Yeah.
able to train with fewer examples and get better performance from it.
Yeah. I think a while back, I forget, I think it was for image models, but they did like a pruning, like a post pruning type system for it, and they were able to cut out like, I don't know, like 90 or 80% of the neurons. Like, well, why did you have them in the first place? Like, what? Well, why were they so useless, right? So I think maybe you're right on the architecture side of things. Like maybe there'll be some sort of advancement, like people finally try to understand why models even work in the first place, right? Because I think there's like a tendency to just like keep on adding stuff just because you got like Peter Thiel backing you up with like $1 billion or whatever. So I hope that would be the case, because then that'd be super powerful. Then just like erase all of the open source ramblings that I just did a moment ago, because now you're back to square one where like a few people can make pretty powerful models. As it is though, I read a paper about like some of these llama and like some of these like smaller ones based off of the ChatGPT outputs. Um, there was some studies that were suggesting that they're not as powerful or even performant, obviously for the fact that they're not as accurate, but in the sense that they're just like repeating some of the core things that they're seeing in the training data, and not necessarily coming up with new inferences. But that's kind of the same exact argument that you say against GPT in general, right? You're like, well, yeah, that's all it's doing for human language in the first place. So um, uh, I don't know. We'll have to see a little bit more. It's so quick, right? We've seen it like grow pretty quickly in the last like 3 months, and not even like computer or like the computing and the internet breakthroughs. We didn't see that fast of trend. I don't think. Well, I wasn't really there for the .com bubble, but I feel like it was not as fast as this.
Yeah,
Hmm?
for sure. That makes sense. And on that point about becoming more efficient, it's really interesting to see how some of the larger, more powerful models are able to learn so much information about the real world. And
Right.
comparing that with something like a human that will have maybe 87 billion neurons, we now have these LLMs that have even more neurons than that, and they're also able to have hundreds of times more information about the real world than is in our brains.
Yeah. Yeah.
And so it kind of raises questions about how, like, I wonder if the human brain is actually being very inefficient with storing information as well.
Right. Well, I think from like the work that I've done with Rinkus, he's imparted like a lot of neuroscience onto me, and I think one of the things that we see, the inefficiencies that you might call it, in like memory retention and stuff, is that the brain, the whole point of the brain is to only capture the information that is relevant to you, right? So it makes sense for the brain to forget a lot of things that like, just like I couldn't tell you what I ate this morning, right? I just went on about my daily business and ate food, right? So the I think the brain is storing information for different reasons, and they have like different goals in mind than LLMs. That's kind of how the brain is. So like you're retrieving episodic memories of some sort, but in the LLM, you want it to be perfect. You don't want to like be rewriting the memory every single time that you access the memory, just like the brain does. Every time you recall it, you have to reform the connections a little bit to be assimilated correctly to your new skills and your new subsets. So that has an unfortunate effect of you misremembering things, but it makes sure that your brain is always like relevant, essentially. So
That makes sense. Yeah, kind of. Yeah, every time you remember a memory, you're actually taking it out, adjusting it a little bit, and then putting it back in
yeah,
its
yeah.
place.
Like the pathways to get to that memory have to be reconfigured because maybe a skill has been like overlaid and related to a certain like riding a bike, skinning your knee. Now you're doing motorcycles, like, oh, remember that time you skinned your knee? Well, don't do that on 60 miles an hour or something like that, right? So you're gonna like remember it slightly different within the context of whatever thought process and is triggering and rewiring towards it. So yeah, your brain doesn't like rewire too much at a certain age, but there's still a little bit of reconfiguring that goes on, especially as degeneration kicks in.
Yeah, that makes sense. So it's been really interesting as well to see, because going back to that point where we went from 32 bits all the way down to 4 bits, we're at the point now where with a 4-bit model that could be loaded up into a 30 billion parameter model can be loaded into a 24 gigabyte VRAM GPU, which is like a commercial grade GPU. So that's really cool to see that like we can get this super large model. Well, not super large compared to some models, but it's way larger than in the past, like this really powerful model. And we're able to finally like put it onto a single GPU. And so that's really cool. And so it'd be really interesting to see in the coming weeks and months as we get more models that are able to be just as powerful and are able to internalize more facts about the world and fit it into just those 30 billion parameters or less. And so just like how maybe the human brain is inefficient, and we've seen that some of the neural networks are inefficient, as we develop and get these more powerful models, they'll become more and more efficient and be able to work with fewer and fewer parameters.
Yeah, I think too, back to your point about like maybe the data being the thing that helps like reduce like the need for like such a large model, right? I think too, if you kind of combine that with the whole concept of a vector database, if you can efficiently and reliably pull information just from a hard disk into memory, then maybe you can even get smaller, right? Like say, like I'm like a car-sized drone or something like that, right? And I need this accurate visual data and instructions to go along with it. That point, it becomes plausible that you're going to want maybe a single GPU, like you're talking about, for inference and for possibly on-the-fly training. I think that's not really a good idea for these bigger models. Maybe for smaller models, like if you have a very specific task. But for like the LLMs, I think if you have most of the storage on like a hard drive, that's where the actual like intelligence come from, is the vector databases. And then you just have like a thing that unravels the data in the correct way that you want it to. Then I think that's going to be the powerful technique that kind of makes it applicable into our everyday appliances. Because because I've done all of this stuff with like the biologically plausible intelligence, I'm always trying to find out like, okay, well, why is a machine different, right? And like why, if we were able to create it, like why would it be any different than a human's intelligence? So I tend to think of intelligence now as there's two parts to the intelligence equation, where you have knowledge, which is just like the potential energy, and then you have the intelligence, which is the kinetic energy, right? You can convert knowledge just like you'll have a strand of DNA that's just knowledge, right? It's just like the instructions to encode like or to make like a protein that makes the eyeball or something. It's the RNA that does the reading and doing the useful things, right? And the intelligence, if you can have as much power as like RNA has to unravel the data as usefully to create a whole body, maybe you can do the same thing with natural language, where you can have a small like a smaller model that's just meant to unravel the knowledge and do something useful with it, right? That's really the only thing that you need to do. So you don't need to have like really strong like consciousness, right? We just need to do something useful with the data that we've stored, and maybe in an architected way, just like DNA is like set up in genes and stuff like that, right? There's only one way to pull that data out. But I think to your point with the data being the key, like the way you structure the data being key in reducing these models, I think that might be pretty powerful in terms of storing in a certain format and just training on that standardized format.
That makes sense for sure. Yeah, it reminds me of this one research paper that came out, I think last month, called Lima, Less is More for Alignment. And to kind of briefly talk about it, that was like a paper where they had a 65 billion parameter model, a llama language model, and they trained it on only 1,000 carefully curated prompts and responses without any reinforcement learning or human preference modeling. And it was able to demonstrate really strong performance, learning to follow specific response formats from only a handful of examples in the training data. So I think that's one example where just 1,000 examples, training examples that are very well curated and put together can result in a really robust and strong performing model.
Yeah, I think I hadn't heard about that one. You'll have to send me the link after this. But yeah, that's pretty hopeful for the open source initiative, I think, because that's the only way that it's going to work is either it's cheap enough for people to just take up the initiative by itself, or there's enough business use case that a bigger company wants the like community to participate for some reason, right? So if anyone's working on that, I think it'll be pretty powerful for democratizing AI because I'm not like a big fan of like the whole it's going to be a Terminators, we're going to need John Connor to save us, but there are some pretty scary prospects when you think about the people behind the models, right? Like these super powerful models. Like you can say Google was always trying to not be evil or whatnot, but their whole job is to extract value from you, right? It's backed by people like Peter Thiel. He literally wrote a book called Zero to One, which is about how monopolies are good, right? So I don't. It kind of worries me that some of these models might be locked up forever, like behind closed doors, and we don't know how they're being used on the public, essentially. And in the sense of all of the births of technology that we've seen in this country, at least, they've been like in the tech revolution, I'd say. Maybe I don't really know too much about the other ones, but if you take the internet, for example, no one said, oh, you can't post this, you can't post this, and you can't post this, right? No one said that. It was like, hey, here's the internet, we created it, have fun with it, and then people were like posting like weird stuff, right? And there was like a weird period in like the 90s with all these shock websites and stuff, but then that kind of became juvenile, and then the community got a little bit more like mature around it, right? But with the models, with these AI models, if you don't let society like mature around the technology and there's only like a few gatekeepers, that's kind of like a new paradigm that we never had to deal with. So that's one of the things that worries me. Don't didn't mean to take like a dark turn, but it is like kind of concerning.
Yeah, that makes sense for sure. Yeah, definitely. There's a lot of power in the models, and so there's some really great upside, but also there's some potential risks as well. Another interesting paper as well that I was looking at is that there's this other paper that came out last week where MIT researchers were able to use like an entailment model in order to generate synthetic data. And so what they ended up doing is creating an approach to longstanding problems of inefficiency and privacy associated with big text-based AI models. And they were able to create a logic-aware model that outperforms models 500 times bigger on some language understanding tasks without human-generated annotations, while preserving privacy and robustness with high performance.
Nice.
So yeah, that's another paper that's really interesting as well. That through these creating a better data set, we're able to get models that are able to outperform models that are much larger. And so that's really where I see some of this stuff going in the near term, is having new approaches to data and to data set curation such that we can get better performance out of a much smaller amount of data.
Yeah, I think too, the brain's not like this one giant ball of neurons, right? That's how most people see it because they don't look through it in a microscope every day, right? I've never done that. But it's actually broken up into pretty clear sections, and each section is like it's doing its own part to contribute to the overall intelligence, right? And to your point, if you can have smaller models specializing in like logical reasoning or like arithmetic or planning or something, it makes a little bit more sense to put that all together, just like the brain would do in like separate sections. And then you have a thalamus like structure which kind of pulls in all of the inputs or all of the outputs from all of these different models, and then sends them and connects them to the diverts them essentially to the correct portion of this little digital brain. So I think if you're saying there's already papers saying like, oh yeah, you just make a smaller, more case specific like AI, and then it outperforms it on these specific tasks, then maybe that's a better route to go, is just make microservices, essentially like little modular microservices of the brain that do specific tasks, and you just hook them all up.
Yeah, that kind of goes into another paper that I was actually looking at yesterday. I think it came out just 1 or 2 days ago, but it's a paper called TART. And essentially what they did was that they created a additional module at the very end of the large language model that was able to use reasoning in order to improve the performance of models. So in the past, like we had the fine-tuned models and we had LLMs, and the fine-tuned models would perform better on certain natural language understanding tasks. And so the idea was that if you're able to train a reasoning module and then take the output of the transformer, the LLM, and take those embeddings and feed it into this reasoning module, then you can actually have the reasoning module make the prediction. And in the paper, they did it in a binary classification format, but they were suggesting that this could potentially be expanded to different, like multi-class classification, for example.
Yeah, nice.
But yeah, just another really interesting idea as well, that's like you're able to take this LLM and then add on a reasoning module on top of it, and then it's able to perform just as well as fine-tuned models in certain tasks.
Right. And this module, the separate module, is just it's a new model, or is it just like a prompt that's
Yeah,
training?
it's a new model,
Oh,
and it's also transformer based as well.
okay, nice. Yeah, so that kind of lines up with the little theory of like a modular architecture for building out brains. So yeah, if they've already got good results on that too, maybe we'll see some more effort kind of moving towards that direction.
Yeah, I thought it was really pretty cool to see that they were essentially able to take this reasoning module and mix and match it with any LLM that they wanted, whether it was a smaller LLM or a larger LLM, and it was able to improve the reasoning of the LLM in order to make decisions.
Nice.
So very exciting stuff coming out there. So to go on to the next question, given how popular text-to-image generation became in 2022, what other types of AI might also become just as hyped as LLMs and image-based applications?
Yeah, so it's a little bit tough to predict that, because there's a lot of things that initially seem like technology-wise, they're like, as a nerd, you're gonna be like, oh wow, this is awesome. But then like everyday usage, you're like, well, how am I gonna use that, right? I don't think I would have ever predicted that people wanted to just like make AI generated pictures all day, right? Like
Mm.
when my brother and I, when we first were using Midjourney, we were just sitting there all day, like so much so that I was dreaming of like Midjourney pictures when I went to sleep. So I think it's hard to kind of predict what people will find useful or entertaining. At least entertainment is kind of like the hardest thing to predict, like what people are going to want, right? In the games industry, when you find a game type, unless you're an indie studio, right, that like has a following that likes just playing experimental stuff, if you're a bigger game company, you have to just stick with what you know, because like any like messing around and you're going to be like down 300 million, right? So I think in a similar way, if you're talking about all this research money, like a research like a senior researcher gets like $300,000 or something, depending on like what type of field that they're in, like vision or whatever. So I feel like there's a lot of different things that you could do, like generated audio voices, right? There's a what's it called? DID, I think it's called. It's like a little like tech. You type in text and then you put in a picture, then it automatically maps out the face, and it will like move the mouth and the head a little bit, and then it uses like AI generated voice. That's pretty cool, but other than people like using it for maybe like filters or putting out like deep fakes or something like that, or maybe having like an animated picture of one of their loved ones or something like that. I don't know how viral. I mean, there will be useful stuff in terms of like people making things just for like little trinkets and novelty type things, right? But you can take those little globes that have like the laser etched pictures in it, right? Like those are cool, but it's not like a multi-billion-dollar industry or anything like that, and didn't go super viral. So I think if I were to use something, if I were to want something that was super useful for me as a like a indie studio, or well, when we were an indie studio, I'd want something to do with 3D modeling. I don't think it would make it like ease its way into everybody's lives, but a lot of there's a lot of programmers who can like program game development, but it's hard to get quality artists who want to do stuff for free, right? It's easy to get programmers that want to do stuff for free because I don't know, maybe it's just maybe it's just a programmer trait. I don't know why, but it's hard to get artists who want to spend all their time um, making something for free that they're not going to make any money off of, right? So I think you could see an explosion in a lot of indie games if those types of things came out. If like a generative 3D modeling, um, what other tools? Oh well, actually, if you just go beyond entertainment, if you think about say I'm a mechanical engineer, but I don't know how to use SolidWorks, which is like a CAD, like computer aided design software. If there was an AI that could help with that, think of what you could make with that. You could have like architect level and mechanical engineer level physicist type machining and design for whatever you could conceive of, essentially. So I think there will be technologies out there that make people's lives interesting or maybe slightly easier, like a bot. Like there's like almost every single text-based thing now has like an app that has like generative text integrated into it directly, right? Either an email or a text message or like I don't know, something, right? And so I think there will be tons of those. Maybe people are getting like they want to describe a filter for their face or whatever's happening, and the AI builds it like on the fly, and then people use that all day long in TikTok or whatever they use, right? So I think you kind of have to decide what industry you're talking about in terms of like what's useful, and if you're talking about virility or value, right? So you can say um, the generative AI art is super viral, but is it super valuable? And I think for some people it will be, but for most people it's just entertainment. So I think synthetic data actually. If I were to say one specific thing that would be super powerful and maybe just viral in general, synthetic data for niche markets. So like maybe you want to like you're trying to train your like surgery students or something on x-rays or whatever, right? Generating images for them so they can't just like cheat or something like that. This is a big problem for programmers. Every time you want to get like a programming job, they're going to give you like some stupid like some stupid interview question that you're like, look, you just use the modulo and then boom, that's the end of the story. That's how you get to the end of the loop, right? But if you were to generate questions that can be posted online that are novel, you can't just like look up the answer to it, right? You could generate these types of programming questions. That's super useful, and it's a form of synthetic data that can improve the hiring process to make sure that people aren't being like over interviewed and not like interviewed on something too trivial that doesn't really accurately depict your skills in a task, right? So I think synthetic data for training purposes could be pretty powerful.
That makes sense. Yeah, it'll be really exciting to see how the synthetic data ends up playing out in the coming months and probably a couple years. Just seeing how even with LLMs, how the text output can then be used in order to fine tune or
Yeah,
used to keep training the LLM and increase the performance of it.
yeah. I think I don't know if you're going to get like degradation on a model's its output, right? Because if it already hallucinates on itself, like the last thing you want is like bad data going into the system, right? So like if it's like training on things like, oh yeah, George Bush was born in the year 1772 or something like that, right? You're like, no, that's not that's not accurate. But the AI will have been trained on this type of data. I mean, I'm sure that's like a fantastical one. We could just pull that from Wikipedia and train on that data. But on the if you're talking about the harder questions that are hard to find as a single source in a single format on the internet, that might be kind of bad in terms of LLMs. Maybe not images, because it's really easy to check if an image is accurate or not. You can just say, "Oh, that doesn't look right," and then you just delete or whatever, right? But if you're talking about things that are hard to look up and maybe they require domain expertise, could kind of get a little bit like degradation out going on in terms of accuracy, at least going on inside the fine-tuned model. So they'll have to come up with some sort of checks inside the system where the data that is being generated can be verified and then integrated. I don't know how you're supposed to do that. Maybe you're going to split this data up into another LLM that uses like these new capabilities for searching the web, and then it can like piece together all of these pieces of information. Then it goes step by step and says, this is why I think you should do it, and it will have all of the sections like citations essentially, and then a human checker can just say yes, approved or whatever, or maybe another LLM who's solely meant to be 100% accurate on checking citations essentially. But yeah, you'll have to bake in some pretty hardcore guardrails, making sure that your data is clean going in. Because back when I was in Spain working at a startup, Microsoft had this Cocoa data set, and it was like labeling cookies as pizza. I was like, what? So like we were wondering why we're getting such bad results, and it's because a lot of the labels were like horrendously wrong, and it probably because they might have like cropped out the things with no context around it, so even human checkers were just getting like bogged down by the monotonous like mechanical Turk style saying pizza cookie or whatever, right? And whatever method they were using to check, though, it was kind of bad. There's a lot of errors in that data set when it first came out.
Yeah, that's a challenge as well, is just making sure that the human labelers are doing it correctly.
Yeah.
And like implementing some type of pipeline to like have someone label it, maybe have another person label it and compare them and monitor each individual person's accuracy in doing the labeling. And if they go below a certain accuracy, then not using those labels.
That's interesting. You should say that. There's a way to gamify that type of scientific research. I'm not sure if you're familiar with the game Eve Online. It's like it's like a massive, like your life will get sucked into it if you play it. But it's like a massive space game. But they decided like a couple, I don't know, it must have been like 5 or 6, I don't know how many years it was after they had released the game, but they ended up pairing up with like scientific researchers who were doing studies on like classifying stars, like, and if they had planets circling around them just by looking at the dips in light. And they would do that system where sometimes they would inject known labels into it, and then you were getting your accuracy assessments based off of the known labels one, but you didn't know which ones they knew and didn't know. And you're sitting there and you're kind of like doing these little tiny scientific tasks for rewards inside the game, so you didn't have to grind so much in the game to get them. So you get like a cool spaceship and then you go around blow up pirates or whatever. So I think maybe when you're talking about that, I was like, oh, that's kind of like the gamified systems that they have. So maybe gamifying it. Maybe there's a company that wants to team up with like you're a researcher in one of these RPGs or something like that, right? Or some Roblox games where kids can verify they have to like look up this data or something, right? So maybe there's a way for the gaming community to kind of integrate with the scientific community or the AI community and verify some of this data, because you need there's a lot of data out there that needs to be annotated, which is kind of the problem with the current trends of AI. But there's ways to annotate it if you have like a motive. That's the thing. You have to have a intrinsically motivated labeler. Or if they're just getting paid, they kind of slack off, right? They're just like, yeah, whatever. I'll do it later, or I'll just go back and relabel it, and then they'll totally forget because they want to go home or something like that. So.
That makes sense. Yeah, very interesting idea of potentially gamifying it and teaming up with maybe some type of group that has a video game in order to get data labeled.
Yeah.
Very cool. So the next question, is it plausible to assert that we are progressing toward AGI simply by developing larger and more powerful LLMs?
I think all of the stuff that feels very human-like is not actually from the model itself. I think it's from language itself. I think all of the inferences of intelligence come from the fact that we've based language around describing our world and describing complex problems, right? The language itself is the thing that is like the description of intelligence, not necessarily the model. The model is just outputting things in an order that we would expect it to see in like natural spoken language or even programming, right? So you could actually say that if I just ran, like, this is a huge programming thing, right? Genetic algorithms, even like Cartesian genetic algorithms, where you'll have like these little functions like lined up in like little rows essentially, and then you'll have the inputs from what you want going into the program. Maybe it's like an image or something, and then you'll have the this algorithm just randomly selecting like where the input goes and then where the next input goes, and then it does really well. They made like filters like in a second for camera filters for like rovers and stuff like that to color correct for like, I think it's like Martian or moon lighting or something. And that's not really that you can say without a shadow of a doubt that's not intelligent, right? Just like shuffling the deck until something useful comes out, right? So in a way, the LLMs are intelligent because they're accurately putting them in an order without randomly selecting them, right? Well, I mean, it's random, but it's probabilistically random, so you're going to get a good result. If it's long enough text, it will be corrected, right? So I think you're not going to get consciousness from an LLM, even if it seems undoubted to you that it knows you, it like is talking about you, it like loves you or wants to marry you or something, right? It's not. You yourself have injected that bias into the AI in that moment, right? If you just like remove parts of the information from it, what you could say, you could remove parts of my brain, and then I'd be completely different. But that's not true because I've had I've had chunks of my brain taken out for surgery, right? So, and I'm pretty much the same person. Like I could see things a little bit different, but that's the human stays stable representation of itself, right? Whereas these models, you take out an appreciable amount of chunk of its brain, it's completely different, right? The probabilities are going to be all over the map, and I think that shows the inherent instability of current LLMs. I don't think it's impossible to get something that is conscious like, in the sense that it can plan its own things and it can do useful things like other humans would do for us. But I don't think the current trend in models is anything towards consciousness. So, but I guess I'd caveat that with we don't really have a strong definition for consciousness, right? Like we don't have a strong definition for what a soul is. Like it's just a word humans use to hand wavily explain like what they're feeling, right? So until there's like a strong definition, I wouldn't even take what I say seriously, because it could be that there is a very mathematical like description of consciousness that you can say without a doubt this is consciousness, right? So I don't think it is, but that again, that's another hand wavy explanation of saying like I don't feel like it is, right? So
Yeah, that makes sense for sure. Yeah, it's tough to even describe, what possibly consciousness could be. So,
yeah.
the debate on like, is it conscious, is it not conscious, is kind of a moot point at that point.
Yeah. I mean, I have a theory of consciousness, and it's based off of working with Sparsey. Um, like Sparsey is distributed sparse codes, right? So the idea of distribution is that the codes in your brain kind of know what is like if I'm triggering like a concert feeling, right? Um, the codes that are like being lit up right there, they're all in the same. We're in the sense that if some of them go out, I can still represent the feeling by describing it to you, right? I don't need to. You don't need to be there a lot of the time to feel the same thing. Like if I can tell a story to you emotionally enough, you'll cry, right? And that's kind of like a. I think that might be a hallmark of consciousness where whatever is happening in the brain is not, it's like entanglement in quantum computing, right? You can't separate the two because they're being represented in a way where all of them, they're only going to fire in that situation, right? And I think that might be like it's, I have no evidence for this, right? But that might be an underlying concept of consciousness where the representation of whatever you were thinking about or talking about, it has to be a uniform representation that all modules are represented. Like when one part of the brain brings it up, the other part of the brain has a um, like a code that represents that exact same thing, but just in its own way, right? So I think that's what consciousness is like a it's distinguishable in the sense that you can classify, oh, these are distinctly different codes, but it's indistinguishable in the sense that they make up a whole experience together as like one giant code. And you can't necessarily separate them out without describing the other parts of that code.
Okay, that makes sense. So, what would you say is the threshold for AGI? How should we define that?
So I don't think we should do it with consciousness for the reasons that we laid out. One, it's one when I was like a year into like AI, so I was kind of like rosy colored glasses, like, oh, I'm gonna make a brain, but I talked to one of these guys at a conference, and he was like a contractor. They were like trying to find like cartel airports, like they have like these jungle airports where they fly in and out, and he was talking about some of the synthetic data about like generating or procedure, like either generating with models or generating with like game technology to make these data sets. And we got into a conversation about consciousness and brain like or like brain inspired algorithms. And he mentioned something that kind of stuck with me for a long time. And he said like, well, do we really want that? And I was like, well, that's what I want, right? Like I want this like cool AI that I can talk to, and like it'll be like a friend or a part of society or something like that, right? But like as I like progressed through my AI career, that like whole sentiment became very clear of what he meant. It's like the goal of AI really isn't even consciousness. It's just to make humans' life simpler. And some of the researchers, they want consciousness, like Rinkus, he wants to build conscious intelligence. Ben Gortzel, he's another prominent AI researcher. He's deeply interested in consciousness. I think he's come down to the realization that it doesn't need to be conscious as long as you're interacting it as if it was, then that's good enough, right? And I think in terms of AGI, you don't need consciousness to be useful, right? What you do need is to do jobs accurately. If we're looking at them as just as machines, right? Not anything more than that. You need to be careful because if we accidentally stumble upon consciousness and we just like built this whole workforce around it, that's kind of messed up, right? Humans aren't really known for being nice to other things that are not like them, and like just exploiting them indefinitely, right? So I think for AGI level, it just needs to be useful in a variety of daily tasks. And I think there'll probably be different AGI like silos. You have like daily life, like a housemaid, like that's not any more useless than like a programmer like me, right? It serves a purpose for society, and like we all play a part in making society go about stuff, right? So I think in the same way, we'll have different AGIs for different tasks, and it'll probably be a lot easier to build as well. And I think they just have to do it accurately enough that you can replace the person doing it, like the human that would be doing it. And I think that would be AGI. So they have to be able to communicate with a human, just like a human would communicate with a worker. And then they have to do the task and understand the task enough to do that task. So you could say, well, that's still specialized AI, but I don't think it's specialized AI because I'm not like a specialized human, right? I don't know too much outside of like programming type stuff. I try to learn more, but you put me up against any biologist, I'll fall flat on my face with that, right? Or any rocket scientist, like I can't even come close to that, right? But I'm not like a specialized human in one particular thing. So I think AGI can be useful as long as it can communicate and interact with human in a safe way, and in a regular, like all forms of communication too. So like body language, um, like spoken language, and emotional like detection. At least doesn't need to empathize with us. It just needs to know if we're distressed or something like that. Right? Because a lot of job like workplace things, you have to tell if the customer's angry or if they're hurting, right? That's even worse, right? If your robot can't tell that you just got your foot crushed by a forklift, that's pretty dangerous, right? So in terms of AGI, they need to know, and they need to know the human environment, the human condition, and they need to operate in it, in what we've already built. It can't be specialized just for them. And I think that is that's a it's like a soft, not really a hard threshold, but that's like a soft threshold that I would say.
Yeah, that makes sense. Yeah, very interesting. So, what do you think is the earliest version of AGI that will actually be useful?
So there's a lot of warehouse bots that are coming out. I think um was it Figure? I think it is. It's like I think the CEO's name is Brett Adcock. They have a it's like pretty cool looking humanoid, and the whole concept of it is to like pick up boxes, move around. And a lot of people are doing this. Atlas is doing this. Um, there's a couple other ones, so like non-humanoid bodies too. Some of them with like bird legs that are walking around. Those are all saying that they're going to replace warehouse workers and factory workers and stuff like that. I think that'll probably be a good case. I used to work in a coffee factory, like those little Keurig cups. I was like 23, I think, and I worked in one of these factories, just like checking these little Keurig. They flush it with nitrogen, and then you have to pick one off the line, pop a hole in it, see if the nitrogen levels are above 98% or whatever, and then you throw it away and just check, make sure the filter is good. And I think if human workers can be converted into managers, their life will be a lot more pleasurable than just being some guy like working in a factory. Like my grandma and my grandpa, they worked in a pineapple factory in Hawaii, and that's all they did, just like chop up pineapples and make sure the cans are sealed up right. And that's like, I don't humans aren't meant to be that way, we organize society just because we're competing with other countries, right? And other companies. uh we organize society that way, but it doesn't need to be that way anymore. And I think a lot of people will get pushed out by AI. I know a lot of people don't think that, but I think the first versions of AGI will be um probably these workers. I think programmers and like data entry will be replaced first, but you won't need to interact with them in the same way that you would like an AGI type system, like based off the threshold I gave you. So you'll have to talk to them, but it doesn't need to navigate the human world. It doesn't need to. Hell, you could make a whole database specifically for that AI, and it wouldn't have to know anything about the human experience, right? And I think that's different for a warehouse robot. That has to be an AGI like system because it's working around other humans. It's working with human materials. Warehouses shouldn't have to be rebuilt just to automate a little bit better, right? So I think maybe they won't be humanoid. Maybe they'll be like little carts with robot arms on it, but they'll have to interact with humans as humans interact with humans. And I think that's will be the first types of AGI that we see.
Interesting. Yeah, for sure. That makes sense. Cool. And then I think our final question, we already touched on this, but do you think the relationship between computation and consciousness is strong enough to enable us to build conscious machines?
Yeah, I do think there's a couple of people who don't think this. Like a lot of biologists, they don't think so. They think that there's something inherent about biology. One of the, I think his name's David Koch. He always uses the example of a black hole simulation, right? Just because I can simulate a black hole doesn't mean I get sucked into the computer, right? So, and that's like his excuse. And in a sense, he has a point in the sense that you're like a black hole is not a physical thing if it's in a simulation, right? But intelligence and consciousness are just information, and it's the way you've like configured information, right? So I think you can get consciousness. One of the biggest problems with that in digital computation you can do it, but the problem is it's not like a huge substrate that can calculate it all at the same time, right? So you necessarily have to move it into the memory, then do the calculation, then move it back onto the RAM or the STD or whatever, right? Or the solid state drive. So I think in a sense it might not be conscious because you're chunking it in a way that doesn't allow all of these codes to interact in like that uniform, like unseparable manner, like entangled manner, I guess you'd call it. But I think you can get the results of it, but it might be a weird experience for whatever is being consciously simulated. So yeah.
That makes sense. Yeah, very interesting stuff here. Cool. I think that was pretty much all the questions that I had. This was very exciting and very fun to have this conversation with you, Codie, and to come out with my first podcast episode here and have you as the guest. So
Yeah. Thank you for having me. Like I said, I think you're putting in a lot of work into this channel, and I think you're gonna have a lot of cool guests on. So I subscribed at the moment you told me. Like you didn't even tell me when you started it. And then I come and I see you got like 1,000 subscribers. So I'm pretty excited to see where you go with it.
yeah, I appreciate that. Yeah, I think I need to get the word out a little bit more.
Maybe, yeah. At least amongst your friends.
For sure. So once again, if you're interested in working with Codie for any consulting projects or you want to have a conversation with him, all of his information is in the description below. Thanks again for watching, everyone.